Good afternoon and welcome to the Sustainable Materials Management webinar series, a joint effort between the National Recycling Coalition and the Pennsylvania Recycling Market Center. My name is Wayne Bowen. I'm the program manager for the Recycling Market Center and will serve as your moderator today. Before we get started with the presentation, we would like to extend a special thanks to Bob Hollis of the Mobius Network for providing the webinar management software for this series, and Savannah Batowski of the National Recycling Coalition for assisting the RMC with webinar promotion and technical support. Today's webinar will discuss animal mortality composting. Our presenter today is Jean Bonhotal, who I will introduce in a moment. Following the presentation, we will conduct a question and answer session. If you have a question or comment, please use the GoToWebinar dialog box located in the control panel on your screen. You may also use the dialog box to request assistance if you are experiencing technical difficulties during the webinar. Please note that an edited version of this webinar will be made available for viewing via YouTube links on the National Recycling Coalition and Pennsylvania Recycling Market Center websites. And now I'd like to introduce our presenter. Jean Bonhotal has worked at the Cornell Waste Management Institute in solid waste education for over 20 years, first working for Cornell Cooperative Extension in Broome County, then for the Waste Management Institute. She works on composting feedstock from food manure to animal carcasses. Currently, her time includes work on food scrap, manure, carcass, and butcher waste, composting, education, and research. Characterizing waste streams is important to be able to separate and determine value-added purposes for different residuals. Compost quality and consistency in the marketplace is also a high priority, as well as encouraging use to build healthy soils and redistribute nutrients. Jean's previous experience includes working with different agencies, including the U.S. Forest and National Park Service, U.S. EPA, New York State DEC, and the landscape and greenhouse industry. She received her MS degree in Education and Communication from SUNY Binghamton in 1991, a BS in Biology from Utah State University, and an AAS in Natural Resources from SUNY Morrisville. And now I'm going to turn the program over to Jean.
Thanks, Wayne. Today we're going to be talking a little bit about routine mortality and emergency carcass composting. There's a lot of need for this type of composting, and I'll go through a little bit of how we got to this point, why this is necessary, why we're composting animals versus landfilling versus other things. First, I'm going to start with the routine stuff, and then I'm going to talk about a couple of catastrophic events that we've worked with so that you understand a little bit about how that's working, because it did affect, some of the outbreaks did affect many states in the United States. So the situation, why are we composting dead stock? Basically, years back, probably 10, 12 years, almost 15 years back, we kind of lost some of our services. We still have renderers, but we lost the ability to process the amount of meat waste that was being collected. And there were a lot of reasons why that happened. Then we had problems with specified risk materials, SRMs, and those are materials that can convey like mad cow, chronic wasting disease to other species. It can spread the disease. So SRMs needed to be removed from the animal, from the dead animal, or they weren't accepted at all. There was a lot of cost involved. People used to be paid to send their animals to slaughter, and then the cost went up quite a bit. Access, everybody didn't have access. Some people have renderers and some people don't have renderers, so that was a problem. We have, this is in the wrong place, I'm sorry, so let me just keep going on that one. Disposal options include, there are some disposal options besides composting, but They include alkaline digestion, and that's chemical digestion, not a regular anaerobic digester. So it's chemical digestion, and that's hard, and there aren't a lot of chemical digestion units around the country. Iowa has some. We have one in New York, or a couple in New York, and there are in various other places, but there aren't a lot. I think Colorado has one. I don't know if it's still in operation or not. But there are alkaline digesters because they are important to have, but they're for more severe disease outbreaks, and they can't handle that much volume. Rendering, as I talked a little bit about that beforehand, it's just not as available. Mass burial, we used to just bury, and we still do. Actually, that is some of our knee-jerk reaction, is just to bury as much as we can. And when we bury, we are bringing it, the flesh waste, 6 feet closer to our water, our drinking water, our surface water, those things. And that just can't be a healthy thing. Open burning, we used to use curtain burners. We still probably use some, but they cause so much pollution when you're burning flesh because it's just a lot of water, that we do as little burning as possible. Even in disease outbreaks, we've had those burners have been shut down because the air quality got so bad. And we can compost, and that's really what we're going to be talking about throughout today, just on different scales. Problems with mortality, disposal, the access to rendering, as we said, the expense and lack of options really are the barriers. There are also risks in, potential risks in composting, composting mortality. And mad cow happens to be one of those problems. So mad cow disease, if an animal is exhibiting symptoms, then we want to really call vets and make sure that what we're seeing is what it is, and then that animal will be taken care of in a different way. We wouldn't be composting that animal necessarily, though we do have some evidence that that composting may be able to neutralize the prions in the composting process. We're just not, we haven't done enough research really to know that that's an absolute. We have to find a site for composting. So it should be away from groundwater, surface water, drinking wells for animals, and drinking wells for people. We don't want anything to infiltrate into the groundwater, into the water, and affect us. So we really want to affect us for our animal health. So we really want to look for those areas that are hydrologically sensitive and avoid those areas, because that can cause problems for us. The first thing we're going to do is lay down a bed. We have a dead animal, so we're going to lay down a bed of carbonaceous material. So chunky wood chips are really good, chopped corn stalk, corn cob. We'll talk about some other ones as we go through this, but there are some on-farm materials and some off-farm materials that work quite well. Wood chips allow air circulation to be optimized around the animal, and that's a really good thing when we're trying to compost, and you'll see why that is as we go through some more of the slides. Place the animal in the center of the bed. The plastic is down because we were doing research on these, and we were trying to look at all the possible runoff from the animal. So we were collecting any leachate that might have come off of that and testing it. And if we do it properly, we won't have leachate coming through there. That's why we put that 24-inch bed of carbon under the animal, under a large animal. Smaller animals we'll talk about a little bit more later, but when we're talking about livestock and a lot of flesh waste, we're going to want a 24-inch bed underneath, and that allows for absorption and biofiltration. If we have smaller animals, those animals can be layered in the pile. These are roadkill deer we were doing on a very cold day in the winter. And we put 2 layers of deer. And one of the things that we learned when we started doing a lot of work with this is that cows are big enough to compost by themselves. 1 cow, the 1,200 pounds or so of flesh, but 1 deer has to be with a few other deer. So we have to have that mass. We have to have the carbon and nitrogen ratio worked out there. And let me back up just a second. This is not a perfect composting situation. So we have aerobicity and anaerobicity going on in the piles at the same time. You're getting a lot of organisms, microbes from the gut of the animal. They're working to break down the animal and all that when we're working in the pile, when the pile's actually working well. So when we have smaller animals, we're going to layer those animals or get them mixed in some way. With deer, they're too big to mix. With chickens, we may be able to mix chickens into a center, but we have to make sure that we have just plain carbon on the outside all around those animals. We also need to add moisture if we're in a dry climate. So dry climates add moisture while you're building the piles. Any arid climates, really the whole time you're building a pile, there should be some kind of water source going into that pile, because the piles tend to heat up and dry out very quickly. And when there's no humidity in the air, it isn't very helpful for the process, and the pile will dry out and dry down and not work properly. Recipes for large animals. As I said, we can take 1 cow and compost that alone. But when we do that, we want to make sure that we have 24 inches, 2 feet of carbon around those animals. Even the tip of their tails and the tip of their feet, the bottoms of their feet. We really want to make sure that there's carbon all around the animal. Sometimes we need to, and often with large animals, with livestock, we really do want to somehow lance the rumen, whether with a knife or a piece of rebar or something like that, because what happens in there, and you'll see it along the highway, when you see roadkill deer and stuff, you'll see those animals have blown up and they will explode actually. And if they explode inside the pile, if it's a hot time and there are no holes in that in the carcass, it can blow up and blow the whole cover off of the top of the pile. And you'll think, well, an animal dug in there, but we kind of can tell the difference between whether the animal blew and whether an animal got into the pile. We have to make sure that we cover the piles, the animal totally. So just another actual picture of how we're doing that. No parts can be sticking out. So oftentimes when we're doing a lot of animals, this can be a problem because you lose track of where animals are. And sometimes you'll have something sticking out of the pile, and that's where the dog or the vulture or the bear or whatever will be attracted to the pile and digging into the pile, and that's where you have your vector problems. As long as you have a good biofilter over the whole compost pile and over the whole animal, you will be okay with, you'll be fine with vectors. And it's really important to do it right all the time, because when you do it wrong a few times and you've trained the animals to come into the carcasses, it's really hard to untrain that. So for large facilities, and you're looking at this is what we consider routine mortality, but if we have 1,000 cows and we have 4% loss per year, we would have 40 cows. And that's a lot of cows. That's a windrow of cows that you're going to be working with. And so the farm generally needs to plan for that. And the mortality rate varies on different farms, but things happen on the farms, and we do have problems with animals occasionally dying on farm. Here you're looking at windrows of butcher waste. And what we do is we lay that bed in the foreground, and then when the bucket comes full of butcher waste, it has some place to put it down. There's no way to put a bucket of butcher waste down or an animal down without getting blood and stuff on the ground and body fluids on the ground. Once you've done that, you're attracting animals to that. So you want to have that bed laid down before you're coming with other material. People ask about centralized facilities. We discourage large centralized facilities in general, because if you have a concentration of any type of waste, you're going to have problems. So this was a situation, this was a business that was called Greener Pastures that was functioning actually very well. And we worked with them to take horses that had died, and they were composting just horses in a field way away from everything. So it worked in that situation, but we worked very closely with them to make sure that it didn't become a nightmare. And that's really what we want to avoid, especially with animal mortality composting. Sometimes people like to use covered bins, the 3-bin, 5-bin, 6-bin system. If you decide that you're going to use bins for it, and bins are used in the South a little bit more, and for pigs more than any other species, sometimes for chickens. But when you're creating those bins, make sure that your loader works in those bins. So you don't want to have a 6-foot bucket trying to fit into a 4-foot opening, because it's not going to work. And oftentimes we forget about the design and what equipment we have, but most of this can be done with equipment that is available already, and we can design for that. So how does this work? The pile heats up, and let me actually, I'll talk about this one. The pile heats up and the heat rises, and that happens within 12 to 24 hours. If we don't get heat in the piles that quickly, then we probably have some problems, and we need to at least think about what we've done and where we want to go to with it. And then that heat rises and goes into the atmosphere. And then more air comes in through the bottom of the pile. And you'll see that in the next slide. Actually, let me just go to the next slide quickly, and then we'll come back to this one. But you'll see the air going into the bottom and the CO2 coming out, and the air just circulates right around that carcass. So we don't do any turning. If somebody tells you to turn a carcass pile, it's probably the wrong thing to do, and you're going to be doing a lot of explaining if that happens. And we've had that situation happen. So we try to avoid that at all costs. It's best in the early stages of composting to leave it static. So if you know how with composting we're trying to add as much air as possible, and with making silage we're trying to compress as much air out of that as possible to preserve the silage. So the processes are opposite, and if you think about that, that will allow you to work through the best way to compost these mortalities. So the time it takes, and again, in 12 to 24 hours, it should heat up. Month 3 and 4, you're going to have clean bones. Mature compost in about 12 months. You may still have bones left in that compost. So if you have a cow or a horse, especially a horse, because they're generally older, they live longer, they're older. Those bones are really hard to break down. Young animals, when we do roadkill, and younger animals, those bones disappear pretty quickly. But the pelvic girdle of a cow, the skull of a cow, and horses' bones, generally, they're going to stick around a little bit longer. So sometimes we have frozen piles. We're composting in the winter. When we look back to that roadkill one, we were composting in the winter. We still want to put them in the pile in the winter, because if we don't, they will melt. When spring comes, they'll melt, and then they're really hard to get into a pile at that point. So we can still put them in there. We had a situation where we started that pile, that particular pile there, and it was -5. By May, the pile had warmed up. Nothing was attracted to it because everything was frozen in there. And then by May, we were able to start the clock and look at the temperatures and at the animals, the deer, were composted. This is just a temperature curve of composting. If you'll notice, this was done in New York late in it was Halloween. So you can see the temperatures outside were cold. We got them into the pile, and you can see those temperatures going up pretty well and staying up for a while, but then we're going into winter, January, February, March. So we stayed in that thermophilic range as long as we needed to kill the pathogens, and then the process still is working after that. The big dips in here were when the piles got wet in the spring. The piles were finished, they wet, and then the temperatures went up again. Disposal of the end product, we reuse it as a base again because then you've added bones. Remove large bones and land spread. So that's possible with roadkill. We're using it on roadsides and planting it down with grass. We don't want it in high public traffic areas in general, but if they're farm animals, they're generally staying on the farm, and that compost is used on the farms. Used in roadside projects and spread on forests or non-human food crops. So some of the feed crops, corn is harvested above the ground, so that will work for nutrients, and it will protect human health, animal health. Now I'm going to transition. I don't know if there are any questions at all, or if we want to stop for any questions on the first part. But now we're going to get into the disease outbreaks. And I'll talk about this in even a more general sense. We have floods, we have hurricanes, we have winter snows that come at the wrong time, or may come at an inopportune time, I should say. There are all these problems that we have where we have mass mortality, and every state has these episodes at some point or another, and it's best for us to be prepared for those as best we can. So I'm going to talk about this in response to a disease outbreak, but this is going to work for all kinds of disasters that are occurring, and that were fires. There was a big fire in Kansas that took out a lot of cows. So these are all these kinds of episodes that we have to deal with. I don't know, when I can't see a raise of hands probably, but I don't know how many of you know that we lost 50 million turkeys and chickens in 2015 to a highly pathogenic avian influenza outbreak. It was all west of the Mississippi. Some of you, I'm sure, are from states where the outbreak did occur. We didn't have anything happening east of the Mississippi. So people that had composting experience and especially with mortality were asked by APHIS, the federal government Animal Plant Health Inspection Service, were asked by them to go out into the field and help direct, provide experience, provide technical assistance for some of the farms that needed help. So there were, I think, 10 of us to start with, which had us really stretched with 50 million turkeys and chickens to deal with. So I'm going to go through some of what happened in these next slides. This was a farm that I came onto in the Midwest, and they were all different sized turkeys. So we come into the farm, we have to figure out what farm preparation we need, what the situation is, because everyone has every farm is different, and every barn is different. So you've got to look and assess the situation beforehand. So we actually provide educational information to the farmers before we ever get on site, just so they have an idea of what is going to go on when these operations start occurring. We try also to get as much information out, like today, as much information out before disaster strikes, so that people understand what they're going to be dealing with. We've got to get on site. We have to look and see what's there. We absolutely have to have carbon sources. We can't just, we generally can't compost just what's on the farm, depending, and I will talk around that a little bit. But oftentimes we will have to bring a carbon source in, and it has to be an appropriate carbon source so that the piles will actually work. If the piles hover around 60 degrees, 70 degrees Fahrenheit, we're in trouble. We haven't killed the disease, we haven't done anything, so we really have to be very careful with that. We spend time with managers, owners, whoever's going to be dealing with the cleanup, and again, provide as much technical assistance ahead of getting there as we can. This is an educational piece that's actually, it got squished in here. So it's laminated. It also can be just downloaded directly to somebody's computer, so that they can quickly see, oh, okay, I have to do this, 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 and this. And it's all the quick and dirty steps of what has to happen in an outbreak. We have these for livestock and butcher waste. We've got them for poultry, for horses, and for roadkill. And that's educational materials that Cornell Waste Management Institute has. There are others out there as well. And there are standard operating procedures that have been developed since the outbreaks, so that we are doing everything in a more standard way. So APHIS and groups of us worked with groups of us to develop a standard operating procedure so that we would know what to do each step of the way. So if there were people that were less experienced, they still had some guidance. We get onto the farms, we've got to be suited up. And I use this picture here because down in the left-hand corner, all the PPE is appropriate. This was the crew, part of the crew that was going in to start with the depopulation. They had all their good gear on, their boots, everything's taped. They have breathing masks, they have all that kind of stuff. If you look up on the top one, the health department came in first in this state, and they provided basically hospital gowns for the farmers to protect themselves. Not much in the way of breathing masks, not much in the way of foot cover or anything else. And these are diseases that we know could jump species barriers. And we're worried that they could jump species barriers. So we really do want to make sure that everybody that's going into these sites are protected, that these sites are cordoned off, and that there are managers at the sites making sure that things happen properly. So we get into these, and these are different people's slides from the outbreak. So these happen to be chickens. We have a situation where we can't even get the birds out of this house because they're in there. There was one doorway in this barn, and we needed to remove these. We would prefer, in most situations, to compost the birds in barn. And you'll see some barns where we could do that. But in this situation, there was only this much space, a 6x10 space, and one door in the barn to manage all of these birds. So they put them on conveyor belts that the eggs would come out in. These were layer houses. So they put them on conveyor belts, and then they offloaded them that way. There's a picture of a piece of equipment sort of shooting birds out. This is all not pretty stuff, but we needed to get those birds out of the barn and into compost piles because they would just keep degrading and cause other disease issues and attract animals. We start by building, and some of the farms we would build some smaller trial piles to show them how to do it. In this case, you're seeing a layer of carbon down on the bottom, and then the birds being layered into that pile, and there'll be 3 or 4 layers of birds, or they may mix they'll mix that material, the birds and the carbon, and they'll put that in the middle, kind of like a Twinkie. I hate to use food analogies, but it gives you the right idea. And then they would put that in, and then they would cover that with carbon. And you see some of the piles, and these are inside the barns here. Again, another layer of birds being put on, and then more carbon. And in this case, they were using wood tub grindings, wood shavings, and I'm talking to more of a solid waste audience right now. I know that there are others on that are agriculture in nature as well, but one of the problems when we have these disease outbreaks is that there's a disconnect between the farms and the solid waste people. Solid waste people generally know where the wood chips are, or the leaves, or other carbon sources, because they're dealing with these things day in and day out, and it all goes to one place or to multiple places in a state. The farmers don't know that. And so finding wood chips in some states is very difficult, sometimes because there's a lot of demand for the wood chips, and sometimes because people just don't know where to look. So knowing knowing that there's an outbreak and that somebody needs some of these materials is really helpful for everybody involved. This is the one barn where we had to move the animals outside. So we have large windrows outside, but they're right near the barn. We try not to move them very far because this disease is airborne and spreads on the air. So we want to be as careful as possible to keep everything contained. I'm just going to show you a video of, if I can do that, hold on, a video of depopulation. And I don't like to get these spread too far in the internet, just because people have trouble with what we do with some of these things. They don't like to see animals being killed. These animals were diseased and dying, and they needed to be killed. So they're using, in this situation, we're using firefighting foam to dispatch the birds. And it's about a 20-second, maybe 15-second video. And I'll just show you, you can see that we build like a swimming pool type thing. It's just metal sides, and then fill it up with firefighting foam. And that dispatches the birds. So I don't think you'll be able to see that video on any slides that you get, but because I'm on my own computer, we can see that. So carbon sources, let's talk a little bit more about carbon sources when we're in this kind of situation. I happen to be in North Dakota, and they were using a lot of sunflower hulls for their bedding, for the animals' bedding. So you can see this up here, the gray material in the right-hand side, the gray material, that's sunflower seed. And it actually worked phenomenally well because it holds its structure. And so we were able to get away with using some of the bedding that was supposed to go under new animals, using that to compost the animals that had died. And you see that the gray sunflower hulls and the birds are on both sides. So we cleared a path, because most of these are dirt floors, soil floors. So we have to clear a path, then we put the carbon down, and then we start mixing the birds or layering the birds on. Down here, we were using some wood shavings, and you can see there, we put the shavings down, and then we're piling the birds on. We never really want to drive over those beds. We want to keep those as fluffy as possible, and that's so that that air can get into the pile. Also on the farm in our bottom left here, there was hot manure on the farm. So they had built this, and I'm actually on top of that pile, and I'm 5'2" for those of you who don't know who I am. That pile is tremendous, and it was hot compost. So we can use hot manure compost from on the farm, and that was perfect because we didn't need to bring it in from any place else. We also, if given permission, can use some biosolids from, if we're composting biosolids, human biosolids, we can bring those in as a carbon source as well. And that, as we know, expedites the process of composting because we're starting with a hot process. And it'll start cooking those birds down and they'll disappear pretty quickly. Normally, a chicken, a laying hen, something like that can disappear in about 16 days, except for the feathers. So all different birds, all different cohorts. We had to mix we did move some birds, some of the real young ones, from one to the other. You can see looks like they have bad hair days here. That is the disease setting in. Some of their heads drooping, things like that you can see in other ones, and then just some of the symptoms. So all different equipment was used on all different farms. We try to use the farm equipment if they have it available. If not, equipment has to be rented. I know these bobcats were brought in and rented, and they are for some of their regular operations. When you're looking at this slide, we're looking at this pile down on the left-hand side is feed. So the feed is maybe how the birds got contaminated in the first place. Not from the feed itself, but potentially from wild birds getting into that feed and wild birds carrying the avian influenza. And that's what we suspect has happened because most of this was in flyways. Most of the outbreaks were in flyways, and it really hit hard in the Midwest especially. So that's feed. If we have eggs, the eggs need to be composted or disposed of properly. They may be landfilled, they may be buried. There are different ways that we deal with some different products. And you see these red things hanging up in the right-hand side, the red waterers. Those are waterers for the animals. We had to haul those up to the ceiling so that they wouldn't be in the way of the equipment. And we dump those so that any water that could have been contaminated would just go right into this. And you can see in these piles, we have very, very, very dry. This was in California, and those piles were very dry. We didn't have to dispatch those animals, so there was no firefighting foam in those piles. So they were very dry. What we had to do in this barn, and it was a very old barn, was they have foggers in there because it was California. The birds can't get too hot. So we put the foggers on to moisten the piles so that the process could start. Different houses, different piles, short piles, tall piles. The piles on the right are about 4.5, 5 feet. That's because we had very low ceilings there. The piles on the left-hand side are, those were about 12 to 13 feet tall. So again, just to recap, the sunflower the sunflower hull was put down in this situation. Some carbon on top of it, some wood shavings on top of it, and then we bailed the birds in there. We have the layers again. We're adding the layers in. And this farm in particular had 60,000 turkeys. So this is one of three 100-yard long barns. So those windrows are 100 yards long. They aren't all perfectly pretty when we build them. Sometimes we have to get up on the piles and make sure that everything is covered, add a little bit more carbon on the top. We're counting on that top biofilter because all the all the air that comes out of all the bioaerosol and the air that's coming out of that pile needs to be filtered. And so it's filtered through that biofilter, and it works tremendously well when we do it right. Clean barn. The barns have to be disinfected and everything afterwards, but that's after we leave. This is as fairly clean as far as a bobcat goes, and then other things, other disinfectants and stuff like that will come into these. So temperatures and release of piles, this was a big deal because we didn't have anything set up. So we didn't know when we were going to release these. We had some experience from low path AI in Virginia. We have the EPA 503s where we have the time temperature regimes that we're following. And so we had to kind of on the fly decide how we were going to be releasing these piles with the blessing of the ag community and APHIS. So we looked at the 503s because they are good rules and they are protective. Should the composting be inside or outside the barn? As much as possible, we want those bioaerosols to stay in the barn. We don't want those moving outside the barn. So as much as we can, we want those inside. We ran into situations, there are fans in all barns, all livestock barns, just to circulate air, to keep the animals healthy. And we needed to leave those fans on because we were working in the barns and the animals, in some cases, the animals were alive. So we had to have circulation in there until those animals were dispatched. So I think we almost needed a filter in those the fans where the air was leaving the buildings. But we did pretty well and didn't have a lot. I don't think we had a lot of disease transfer from farm to farm. When are outdoor piles done? So indoors, we left. So what we decided to do was to check temperatures for 14 days. If we got to reached our time temperature in those 14 days, then those piles, because they had birds in them, those piles could be turned outside the barn, and then we could start the disinfection process of the barns, so we could get things going. If they didn't meet those time temperatures, then we had to some of us looked at the temperatures and decided where we wanted to be. APHIS really wanted 131 for the 5 days. So that's what we were really looking for. But sometimes if piles aren't built perfectly, you don't get those temperatures. And so we had to work with some of those other piles. And in some cases, rebuild or turn in barn or just to get more air into those piles. The outdoor piles were sitting there for a while, but really, as far as the disease outbreak went, all that we really cared about was that we didn't have disease in the piles any longer. And then they could be done with that. Then, technically those piles could be released. The compost isn't done for, I like to see it sit for 6 months, 6 to 9 months, especially in those situations, because we had very large piles. We had miles of piles in different places. Compost use, we expected the farms to use the compost afterwards, and it was good, clean compost, had good nutrients, so shouldn't be a problem. Tips for cold weather composting: use taller piles, make sure they have really good carbon sources, good chunky carbon sources, a good cap. If birds are frozen, there are different things that can be done. Either, one of the best things that could happen in best case scenario for all of this is that the farmers that need to respond to something like this would have some practice ahead of time. And if you have a hot pile of animals that from your routine mortality, animals that are dying, then you can go ahead and use that for your hot compost and keep going. And again, biosolids, I mentioned earlier, the possibility of biosolids or poultry manure compost that's already working. So if the farmers are doing some practicing, then they're going to have a leg up and they're going to understand what they need to be doing and be ahead of the game. Birds can be incorporated into the piles frozen, but if they're in the piles frozen, they're going to be preserved frozen in those piles, and until the air temperature comes up and warms them, they are not going to melt. Because if you remember, in the old days, we used to keep ice in sawdust and shavings, and that's how ice was preserved through the summer months. And that same thing will happen with these frozen animals, is they'll stay cold, so it takes some time. Partially frozen piles will allow that ripple effect. So if we already have started it and it's hot, then we can get that to ripple right down the windrow. Prior to disease outbreaks and disasters, as I said before, we want the farmers to be practicing. Compost covers were brought up, and I'm not opposed to compost covers being used in this type of situation. However, we would have had to dispose of all of those compost covers in a landfill, and it would have been very costly, and we would have had contaminated material that would have had to go over road because it wouldn't have reached temperature. The polyester and the Gore-Tex wouldn't have reached temperature, and we could have had disease transfer just going over road to the landfill. So in this case, it probably wasn't good. And those biofilters really do work very well to do that. When managing frozen piles, the clock starts when the pile starts getting hot. So we really have to keep that in mind, and that was something to remember. When responding to the unknown, just as a wrap up for this one, understand where the farmer and farm managers are coming from. These guys are devastated. They've lost millions of animals, lots of money. Some of it's compensated for, but it's just when you lose any animals, it's shocking and overwhelming. Take weather into account. Are we in winter or summer when we have these outbreaks? Spring, fall, rain, wet. Assess which are the best methods to use for all of the materials that have to be dealt with, as we were mentioning. Develop guidance that's flexible, that addresses, but addresses at the same time, addresses all situations. Everything is going to be different, so we really do have to use our heads when we're in there and say, yeah, that'll work and that'll be okay. Are we more prepared than our first high-path avian influenza outbreak? Definitely. We have SOPs, we have more guidance in general for these. So we are a little bit ahead of the game now. I'm going to go through just about 4 or 5 more slides and then open it up to questions. In New York State, last year we had, I'm Mark King and Jean Bonhotal right now, because 2 of us were going to be doing the webinar and 1 of us ended up doing it because Mark King is involved in the main compost school right now. We had a brucellosis outbreak in feeder pigs in New York State, north of the Albany area. And we had about 270, in the end, it was about 270 pigs that had to be composted. They were all different sizes, from tiny, tiny little piglets to 1,000-pound animals. And again, airborne, we needed to keep things. In this particular situation, the farms weren't suitable to compost the pigs on farm. They were either wet, too wet, and there would have been more problems with disease and disease transfer because we would have had too much leachate and other things. So we decided to, the state vets take over in most of these situations and sort of guide us through these through how we're going to be doing things, and everybody sort of agrees on this is how we're going to do things. But the state vets decided that it would be better that if we bring it to another place. So the pigs had to be shipped in, and then they were killed on the other farm. It wasn't a pig farm. It was another type of farm, and we were a good mile away from any other livestock in this area. And it had high walls, as you can see, the hills. It's down sort of in a pit. So we were able to set up the windrows in there without having a lot of problems with odor, and we shouldn't have odor from these as long as we have good biofilters and bioaerosolization. The vets came from lots of different places. We had people from as far away as North Carolina and Massachusetts, and the vets come in from other places. We're the only non-vets that are there generally. But you can see all different types of pigs, all different sizes of pigs. This happened to be a first layer, and they're taking samples from each pig to confirm their status, their disease status, just so that we know what was happening, because we couldn't confirm every animal ahead of time. But if they're in that herd, then they have to be destroyed. They needed to be destroyed because it's pretty easy to spread this disease. We've got to get the pigs over to the piles. So after they're killed, these were killed with captive bolt. After they're dead, we pick them up, we bring them over, I unhook them, we get them into the windrows. One of the pigs, and this was a stud pig that was shipped to Maine before we knew that there was a disease outbreak. So this pig was followed, and it was a breeder pig, but it had not been with any other animals. So it hadn't been on a farm yet. I'm not sure why, but it hadn't been. So this animal was dispatched, and that was composted in Maine. But we were able to track, they needed to know where all the pigs from those farms went to and all. Not that it would cause a problem with human health, possibly, but we don't know. And this disease outbreak was actually picked up in a human. So we know that it can jump, and that's how we found out that the pigs were sick, actually. This is the first finished windrow there, and we used a combination of wood chips on the bottom, hay and straw, because we were short of wood chips. We're pushing up against a weekend, and we needed to get chips, and the landfill that we were going to get chips from, it was availability. So it was time and availability. So the landfill was generous in giving us good chips. We had to ship them to this location, and then we were able to use that as the bed. And then we used a lot of the on-farm material from the other animals on the farm that was shipped down to this yard, and we used that as cover in some cases. The vets did notice that where we were using more wood chips, we had hotter temperatures, but we still reached our temperatures in this situation. This is just a slide that has more educational materials on avian influenza, poultry composting, more information, more conferences that we do. There's actually a conference that we do every two and a half years that looks at management of animal mortality in carcasses, because it is such a big deal when somebody has an outbreak. And we've had practice with chickens now, and we had practice with chickens and poultry and chickens and turkeys, in the past with low path AI, but now we have it with high path AI. We have a little bit with pigs in other places, some from disease, some from drowning and things like that. We have lots of cows that are being put into piles as well in some of these storms and other issues. If we have a disease outbreak in cows, it's going to be a big deal, especially if it hits places like the Texas Panhandle and Kansas and, you know, some of the other places where we're raising a lot of beef and we have a lot of animals in close proximity. So we prepare for those things. Our next conference will be next spring in Amarillo, Texas in June. So that one will be coming up and is starting to be advertised right now. So, oops, I'm sorry. I just totally messed something up. Okay, back. I can't go backwards, sorry.
If you hit your last slide, it'll go back to the non-presentation mode, Jean. So anyway,
okay.
So it sounds like you're pretty much done.
Yes, I am. That okay. I was just going to the last slide there. Sorry about that, and I hit the wrong thing.
If you press on the slide itself, you can advance them, I believe.
Yeah, I think we're going to go through everything now. Okay. I don't know how to get the last slide.
Yeah, meanwhile, I will.
You bet.
I will finish up here. We're going to open it up for some questions. So if you do have a question or a comment, please use the dialog box. And we already have some questions from presented during the presentation, so we're gonna go through them. Jean, while you're doing that, could you just go over a little on the some of the composting requirements? Just confirm the recommended depth of your bedding, and then your time and temperature requirements.
You bet. So when we're putting down a bed for livestock, for large livestock or lots of animals, we want 24 inches. I like 18 to 24, but 24 is better because that allows for more absorption. With poultry, when we're doing, you know, routine stuff, we can have 12 to 15 inches, but the 24 is going to give us a little bit more. That air plenum on the bottom for all composting. The air plenum on the bottom is so important because the air needs to come in from that point in the pile. And if it doesn't, then the whole process stops, and then we have to start over. Time temperature, we want the time temperature to reach 131 degrees Fahrenheit or higher for 5 days, 5 consecutive days. And we'd like it, you know, with the disease outbreak, we look for even a little bit longer. But it's the same rules that we use for food scrap and biosolids.
Okay. As far as downtime, what is the typical downtime for a farmer from, I guess, from, you know, discovery of outbreak to given an all clear sign and he's able to resume operations?
It very much varies. So it's going to vary. That's not a question that we can answer. It's a farm by farm kind of thing. It could be 3 months. It could be 6 months for the poultry. For the livestock, we haven't looked at that yet. And for the pigs, I honestly don't know for the pigs that we did how long they had to wait to be able to bring more pigs on. But with the turkeys and chickens, it was anywhere from 4 to 6 months.
Wow. Okay.
And honestly, they want, you know, the production facilities want to get up and going as quickly as they can, but we've got to make sure that the disease is not anywhere on the farm and not going to potentially start all over again. And believe me, the farmers, I think, understand that because it's such a tough job to do when you have to compost this many animals.
Jean, have you come across any operations that utilize the in-vessel, particularly the drum, rotating drum composting, and have you seen grinding as part of the preparation of the mortalities prior to composting?
Okay. First, the drum one. I'll answer that one first. So the drum composting, yes, there are some good drums out there. It's hard for a disease outbreak, it's hard to keep up with something like that. And I don't think you could possibly put them in drums. We just had too many. But for routine mortality, there are some operations in Pennsylvania that use drum composters. There are some in Virginia, West Virginia, but that's going to be for more routine and regular mortality. We haven't tried to do that in large scale because we've got to get those animals dealt with pretty quickly, and the drum isn't that it speeds things up a little bit, but not that much.
Have you seen any research on animals who receive pain medicine or antibiotics shortly before death?
You want me to answer the other one first?
Oh, I'm sorry. Go ahead.
You asked me about the grinding.
Grinding, yes.
So with grinding, at this point, it's not being done. It would be helpful to size reduce, but it's really a grueling job. It takes really strong knives. Even the rendering operations, they have to work pretty hard at keeping their knives sharp enough and good enough to actually grind. Bone is really hard on knives. So it's hard to do, and we're more afraid that it will aerosolize. So we don't want to spread that disease. If we start mixing things up, we want to handle those animals as little as possible. So we're going to move them to the side. We're going to scoop them. We're going to put them in the pile. We're going to cover them as quickly as we can. If we move them around, if we turn them, manipulate them more, everything we do is going to have potential to spread that disease. So we don't want to do that.
Okay.
So at this point, there was research proposed, but the research has not been funded to answer that question.
Okay. This has to do with the foam. I guess the one attendee wanted to confirm what the purpose of the foam was, and then is there any problem with the foam in terms of using it or it being incorporated into the finished compost? Are there any issues with the foam?
Okay. Foam removes oxygen, so the birds can't breathe. They can't get oxygen, so they die pretty immediately.
So it's a tool for euthanizing the animals.
Yes. Mm-hmm. Oh yeah, I'm sorry if I didn't get that across. Absolutely, that was for depopulation, we call it. So it's for euthanizing or depopulating. Mm-hmm.
And just for information, I tried to forward this to everybody. There is a YouTube video on using the foam to depopulate. I don't know if you got it, but if you just do a search, you could probably find that.
You bet.
So
Yeah.
Let's see.
So there was another part to that question. Use of the compost afterwards.
Yes.
The firefighting foam is proprietary, so we don't know exactly what's in it. The compost have been tested after they've been used. We think it's okay. That's the answer that I can give you.
Yeah. I was told it contains CO2, basic chemical.
It does, but there's other carriers.
Yes.
Like there are other things in it, and there are different formulas also, and we generally aren't going to know what that's not part of the job that I do. So I don't know about depopulating. I don't know that stuff. I might have to help with it a little bit, but I don't know anything about that. I just follow directions.
Okay, this question is the mortalities composting utilized at veterinary schools?
Is it used at vet schools?
Yes.
It does. It is used at some vet schools. Cornell has too much waste so we're a large vet school. We have too much flesh waste to do it. We could, but we'd have to dedicate a lot of land. We have different diseases coming in. We have different problems, animals, and they're often different people's animals. So we don't even know the history of all the animals. So the animals that Cornell receives, those are, we have a large alkaline digester. We used to have an incinerator, and when it aged out, we were not allowed to replace that, so we had to find another option. And we do quite a bit of mortality composting here, but with different animals. So our teaching and research center did do that. And to answer it for other ag schools, yes, other ag schools do compost some of their mortality, but they may not be able to do the majority of the stuff that's coming in because of disease and not really knowing what all the stuff is.
There's another drug question. Does composting break down the sodium pentobarbital used for euthanasia into animals?
Good question. Yeah. We did research prior to this, and that's the pictures, some of the pictures of the horses that you saw there. That's what we were doing. Those animals were euthanized with pentobarbital, and we were looking at the degradation of that medium. And yes, we did it. It was done in Colorado. It was done in Oklahoma. And am I forgetting anybody? I think we did a little bit in Virginia. So we've done it in a lot of different places to make sure that we got to levels that were below toxic. So if I don't know if you understand the whole process, but an animal euthanizes, a vet euthanizes an animal, and if that animal isn't properly disposed of, and another animal gets in it, especially a bird of prey, there's major problems. If it's a dog that's gotten in and started eating the animal, it will usually sleep for a week and may or may not wake up. If it's a wild bird, a bird of prey or something like that, which they're feeding on carcasses, they will not make it. They almost definitely die of the pentobarbital. So it's chain of custody. It's almost up to the vet to make sure that the farm is going to properly dispose of that animal and that it's taken care of in a quick manner. So yes, it breaks down in the composting process. We even saw some breakdown of the pentobarbital in the mesophilic temperatures. So that was a good thing to know, but it is throughout the animal's body in about 6 seconds. It's you know, all over. It was amazing. It's amazing how fast it, you know, just blows you away.
Speaking of mesophilic, can anaerobic digesters be utilized as a disposal method for mass mortalities?
If somebody's so inclined. I would worry about the bones because the bones aren't going to be digested. They'll just fall to the bottom and they'll be problematic afterwards. If it could be ground, probably. And some of our farmers have said, you know, can we, you know, grind into the anaerobic digester? If somebody's so inclined to do that, yes. I haven't run into anybody who's done it at this point. And I think when you have a multi-million-dollar digester, farm digester, you might not wanna think twice about whether it's going to hurt that digester or not, bone-wise and other things.
Okay. Did these compost operations generate any odors, maybe as a comparison to a typical compost site?
There really shouldn't be any odor. If you have that biocarbon over and I want a good 2 to 3 feet biofilter over top of those animals. And it seems like, oh, I'm wasting wood chips, but we're really not wasting wood chips. That biofilter is well worth it. And when that happens, we don't have any odor. I'll just tell you an anecdotal story. I was at Empire Farm Days, which is a farm show that we have 20,000 people from the Northeast at. And I had a demonstration there of a cow in a pile, and I went off to lunch. And when I came back, somebody was eating lunch on top of the pile. And I had no idea what they were doing. I said, you know, there's a composted cow under you. And yeah, they didn't know. Okay. So generally, if we do it well, we don't have a lot of leachate coming out. Leachate is where we're going to get a lot of odor. If we've laid our beds properly and have our proper biofilter, we really won't have much. When we were collecting everything from the horse, because we were looking at the pentobarbital, from a 1,200-pound horse, we had the equivalent of 2 quarts of leachate that came off of that. And that's because all the other leachate went into the wood chips, was absorbed.
Okay. All right, we're just about out of time, so we're going to wrap it up here. Again, this webinar, like all the webinars in this series, has been recorded and will be made available via YouTube links on both the National Recycling Coalition and Recycling Market Center websites. Thank you again for joining us. We will hope you will join us for next month's webinar, and please visit the NRC and RMC websites for schedule updates. And thank you again, Jean, for taking the time for this interesting presentation.
Thanks, Wayne. Glad to do it.
Okay, so have a great day, everybody.
Bye-bye.